All right, we'll be getting started now. Everybody here, if you guys have questions during the lecture, just feel free to raise your hand, and depending on the time, we'll just call on you and answer your question. If you're on Twitch, just watching this live, you can also just post in a Twitch chat. We'll be having a few devs monitoring that and answering questions there. So today's lecture is intro to Java and getting started. Just for a general outline of sort of what this is going to look like. We'll first be walking you through how to set up everything on your computer if you haven't done that already. This includes IntelliJ IDEA as well as Eclipse. The terminal instructions are pretty easy to follow. If you're having difficulty with that, just message a dev on our Discord or afterwards after this lecture, and we'll help you out. After that, we'll get into a bit of coding in Java. We'll run through a couple of files, and then we'll go into a robot player, and we'll make a couple upgrades to the example functions player, which has a lot of places it can be upgraded. So let's get started with the IntelliJ IDEA installation. So this is the website, play.battlecode.org. You can just access the getting started on the side panel here. So if you guys don't have an account, be sure to just register and you guys should get access to everything. I think if you don't have an account, you should also be able to access this. So don't worry about that. And if you look here, the installation has everything you need to just get it set up on your computer and start running bots against each other. Battlecode is in Java 8. Higher installations will not work. It's something that we're looking at to maybe get fixed next year if possible. But you can download JDK version 8 over at this link over here. You can just download it and look for the version that's compatible with your computer. The download should take a while. So if you don't have it downloaded yet, I recommend just downloading it either now or on your own time. Either way, it shouldn't be too hard to follow the lecture, and this will be recorded on Twitch and uploaded to YouTube afterwards. Next step is actually downloading the Battlecode 2023 scaffold. This link is right here, and if you navigate here, it's just going to bring you to our Git. For those who aren't too familiar with Git, don't worry, lecture 4 is intro to Git, so be sure to tune in and go to that lecture. It's a pretty important lecture, I would say. Besides that, don't worry, we'll walk you through everything you need to know to get it set up today. But this is a pretty important link that you should just keep in mind and have ready. So the first step is you want to download this 2023 scaffold. There's two ways to do this. The first way is just downloading the zip file. So to do this, if you enter this page and click the code tab, you can just see there's a download zip. And and you can just click this, and it'll get a nice zip file, which you can just unzip and place the code wherever you want to operate for the season. Alternatively, you can pull it from Git, which will also track any changes we make to the scaffold repository. To do this, you can just pull up terminal or command line, depending on what computer you're running. I have a nice file here, a folder here called intro Java, where I want to keep all my stuff. So right here, I'm going to try to pull the Battlecode 23 scaffold, and this will just bring in all of the tools I need to run a bot. So to do this, I just type in git pull, and I just enter in the link of the Battlecode 2023 scaffold right here. So clicking this will just copy it, and I can just paste it into my command line. Oh, whoops. Not pull, I meant git clone, and then just clone it into my side. So if we look at my file system now, you can see that the Battlecode 2023 scaffold has magically appeared. Either way sort of should work fine for this lecture. And it should be pretty easy. If you're having any difficulties, just type into a chat, type in the Discord, or ask a dev afterwards in office hours. The next step is just going to be following down to the local setup. Now, there's 3 ways we have on our website for setting it up locally. We'll be running through, as I mentioned earlier, the 2 IDEs. Terminal is fairly straightforward to set up itself, so you can just follow the instructions step by step, and it should work pretty well. So I'll be running through the IntelliJ IDEA Community Edition setup now. So to set up IntelliJ IDEA, first you want to install the right Community Edition. We have the link right here, but I already have an installation just for this lecture, so that we don't have to wait like 10, 15 minutes for this to get installed. So here is sort of the page that should pop up the first time you actually open up IntelliJ IDEA. You might not see all of these random projects. These are just random things I've been using IntelliJ IDEA for in the past, mostly all Battlecode related, since that's really the only time I used IntelliJ IDEA. But if we look at the instructions, the next thing will tell us to just navigate to import project. So we can go to file in the top left, and under new, there's actually going to be project from existing sources. Our website isn't fully up to date. If you want to use IntelliJ IDEA, you want to go to this tab instead of what it describes in the first 2 steps. Once we hit project from existing sources, it's going to bring us to our file system. And we just want to navigate to wherever we put this Battlecode 23 scaffold earlier. So I put it in my intro Java folder. I can just click on this scaffold, and I want to specifically click on the build.gradle file. This will give us a lot of tools that we can work with afterwards that are really convenient. So just going to double click that file to open it up. And this is now the Battlecode 23 scaffold in all its glory. And it should have everything that you need to run client and run bots. So what exactly is in this scaffold? Well, these are the file systems on the left. This is just all of your code, all of your files that come with it. And under source, you'll find example funcs player and robot player. Now, robot player is sort of where all of your bot code goes. If you guys enter this and then just modify any code here, it'll reflect when you run the code later. Example funcs player is the default name. It's pretty easy to rename, but we'll go over sort of what that looks like afterwards when I start working on the bot towards the end of the lecture. Now, to actually run everything in Gradle, we want to navigate to the right side here. There's a nice little elephant icon with the word Gradle under. Not the most obvious thing, but once you click it, it sort of pops up and it's pretty obvious afterwards. And under tasks and Battlecode, you see a lot of random functions that you can run here. So the important ones, the most important ones that you guys want to keep in mind, update will essentially pull any new Battlecode versions. So if devs make an update on our side, let's say we add new functions or we make a patch where we buff certain robots, update is the first thing you want to go to update it on your end. So if I just run update right now, double click it, you'll see that it has updated already. Now, the next thing is build. Build is essentially just going to compile everything on your end, make sure everything is in order. If I double click this, it's just going to check everything is working, and I believe it's working on it right now. The first build is going to take a little longer, but you can see it just succeeded. The last thing is run. Run is arguably the most important thing. You just need to use run to actually run bots against each other. So if you double click run, the first run is going to take a while since it needs to install quite a few things. Actually, this is, okay. So this is why we don't skip steps in the thing. I'll come back to this later. Run is essentially how you run robots against each other. But as I was just reminded, we are not actually done with the steps in the IntelliJ IDEA installation. So you see, after actually getting everything set up, we actually need to set up the JDK properly. To do this, we can go to IntelliJ IDEA and go to preferences on Mac. I believe on Windows, it's under a different area, but the instructions should have that pretty clear. And we now want to navigate to build, execution, deployment, build tools, and Gradle to select the right Java version. So under here, we just navigate to build tools and Gradle. And we can see that my Gradle JVM is project SDK 16. This means it's in Java 16, not Java 8 as you want. If you haven't installed Java on your computer before, it should default to Java 8. If you already have a pre-existing installation of Java like mine, you'll need to change this to Java 1.8 and apply this just to make sure that we are running in the right version of Java. Just to complete our checklist, we can now do our first build, and we can sort of go back to what I was doing earlier. If we click build, it should once again build everything, and then we should be able to just very nicely run everything afterwards, unless it doesn't like it because I'm a lecturer. Okay, looks like it worked. So you can sort of see some general logs. These are just robots talking. It comes with the example funcs player. If you want to make sure they don't talk, I guess you can delete the print statements. Or if you want to make them more talkative, you can also add print statements. So if you sort of dig through this code, you'll see like robots saying hello here and all over the place. So now Maggie's going to walk us through an installation for Eclipse. And then after that, I'll go over sort of how to use client and how to run games, maybe in a more in-depth way. And we'll enter the intro to Java section of this lecture.
Okay, so if you don't want to use IntelliJ for whatever reason, wait, what happened here? You can also use. You can also use Eclipse. So basically from the same website, when you go to the, wait, hold up. When you switch to Eclipse, it has the same instruction manual, but for Eclipse. So over here, you can also download Eclipse. We have already done that also just to save time. And then once you open it and you launch your file, so from here, you want to go to, File, and then Import, Existing Gradle Project, and then Next. And then you also want to go and find the scaffold that you have downloaded from Git. And then you don't have to click anything here. You can just simply open it and then finish. And then that's it. That's just the setup for Eclipse if you want to use that instead for Battlecode.
Yep. Some other side notes just to keep in mind when you're using Eclipse. I believe it's included in these instructions down below, but make sure that your Gradle is on the right version. We'll cover that and make sure that it's in the right version in a second once we start running code. But now let's actually look at, how you can actually see things in a way that isn't a bunch of print statements or guesswork. We have something called a client. If you haven't opened the client before, highly recommend it. It's so cute. Just go to your Battlecode scaffold, click this client folder, and you'll see our Battlecode client application. You can just open this, double click it, and this should just open up our client very nicely. Now, how do you actually use our client? Well, hopefully it's self-explanatory, but I have 6 tabs here. Game just contains a lot of stats, things that might be useful for you to look at while running a game. Queue is used to run a match replay. So the way it works when you actually run things is you'll run a match, which will generate a match replay file. Match replay file is, just a bunch of raw text and numbers, very hard to read. When you upload it, let's say I just have a random game lying around here, it'll pull up on top of the actual interface. After this, you can just sort of use these top bar menus to play a game. You see this game. I think this is like an upgraded example funcs player I was playing around with earlier. But there's a few things. You can see the clouds. You can see the conveyor belts, the islands. You can see blues captured this island. And then you can see some impassable and passable squares. And our very cute robots. Anyways, if you don't want to see anymore, you can just hit remove, upload new games, etc. Runner is a good way of sort of selecting different bots and playing them against each other, as well as selecting what map you want to play them on. Right now, our runner is a little buggy, so we should be releasing a fix soon to fix it. But for now, you can actually run games from terminal, and I'll be walking us through how to do that later. The profiler is just sort of selecting teams and robots. Personally, I honestly don't use the profiler too much, so I don't have too much to say about it, but I think the map editor is pretty useful. Map editor is sort of how you can actually make new maps. The devs give, I think, 4 maps as default, but if you want to make new maps to see how your robot acts, sort of just paint new things. You can go to robots, add some headquarters. You can add resources. You can add islands. And once you're done, you can just export the map. You can reset the map if you want to delete your progress, and you can also play around with different map dimensions. The help tab is just a help tab, so I have nothing to say about that. All right, so this is our client. How can we actually run things outside of client? Now, if we go through the Gradle tasks the same way we went through with IntelliJ, we can see Battlecode 23 scaffold sitting here. And first of all, we want to do the same things. We can just hit update. We can also hit build to make sure things are built, and then we can hit run to actually run a game between two bots. Now, this might work. Right now it's working on my system because I already played around with this a little beforehand. In case it throws an error immediately when you run your example funcs flare, this might be because that your Gradle is not configured to the right version. So how can we configure it to the right version? We want to enter Eclipse and preferences, then we can just navigate to Gradle. Once we click Gradle, the thing to look for here is Java Home. Java Home essentially indicates where to look for running Java. Once again, we want to run on version 8, and the version that is the default for your computer might not be 8 if you had a previous version installed. So if it's not Java 1.8, you can see it's 1.8.0.0202 on my computer. You can just browse, find where it's installed, and navigate to the home on that to make sure that it's configured properly. All right. So let's actually get into some intro to Java now that everything is out of the way. Before we get into intro to Java, I don't know if you guys have been setting up in the meanwhile, or if you guys set up before and had difficulties, but do we have any questions? Also in the Twitch chat. All right. If you guys have some specific issues that you guys are running into with this afterwards, just come to us after the lecture and we'll help you guys out with that. Until then, let's now enter the coding section of this lecture, the fun part, or maybe not the fun part, depending on who you are. So I've configured a nice Battlecode 23 lecture file here. There's a few files we'll be navigating through today. We'll be starting with type safety 1, and we'll work our way through the 4 type safeties, comparisons logic, and we'll take a look at the robot player and add 2 upgrades. Yes. Yeah, sorry, is that better? All right, so Maggie's gonna walk us through the 4 type safety files.
Okay, so this first one is mainly just going over a few basic variables in Java. So the first one, this one's going over primarily integers and long. So first, let's assume that we have an integer called mana, and we are setting it to 100,000 just units. And let's say that we want to perform this operation where we want to see what 100,000 squared is. If this were to be an int, does anyone here think that this would work? It would give the correct answer. No, okay, that's good. So when we run this, it gives us this number, which is not what we would expect for 100,000 squared. And that's because the upper limit for integer in Java is 2 to the 31st, which is a lot smaller than 100,000 squared. So to fix this, we can change this to a different type, long, which I believe has an upper limit of 2 to the 64th. And when we run this, it does give us what we would expect. Something to note, though, is that while the type of this was int, there was no error message or warning that it was giving the wrong answer. So if you have a code with like many integers and you're multiplying like really big numbers, it might give the wrong answer and you wouldn't know. So this is our second type safety, going over basically how to cast different variables. So if you have done Python before, if you want to like change an integer into a double, you don't really have to do anything. It just automatically does it for you. In Java, it's not the same. You have to manually cast it to change it from a double to an integer and vice versa.
Wait, Maggie, what's a double?
Well, a double is a decimal. So basically integers are anything that are like positive or negative, just whole numbers, and then doubles are decimals. So let's say that this was actually a real bug, by the way, in our code that we found a few days ago. But let's say that we have a game board of unrealistically high islands. We have 100 islands on this game board. And to win, you must conquer at least 75% of the islands. So to initialize this, we also have the word final, which basically means that this variable won't be changed at all throughout the class. So now we want to have this integer of islands conquered, assuming that you have won 75% of the islands. You just do islands times win percentage. And as you can see here, Java is not very happy with this. It's red and underlined. And when we run it, it throws us this error of cannot convert double to int. So does anyone think they know what is going on here? Yeah, that is correct. So in Java, basically when you multiply an integer and a double or a decimal, it will give the final answer as a decimal, even though in this case, 0.75 times 100 is 75. It turns it into like 75.0, so a decimal. So when we have a double or a decimal on the right side, but we're saying on the left side that it's actually an integer, Java, again, doesn't really like this and there's this error. So we can fix this by casting it as an integer. And then when we run it, it will now give us the correct numbers. Something else to note though is that if we had, say, 10 islands, this would not give a whole number when we multiply it by 0.75. And when we run this, we can see that Java rounded 7.5 down to 7. And this always happens when you cast to an int. It basically just chops off the decimal. Any questions on variables or casting? No. Okay, great. So next are, let's say like we have a lot of numbers that we want to all group together. Instead of like having 10 or 100 different integers as variables, we can have something else called an array. So basically over here, also note that in this class, we have private static, which basically just means that it is an instance of the class and it belongs to the class and not to a specific function. But let's say that we have this array of numbers, which by the way, also arrays are analogous to lists in Python, if anyone else is more familiar with that language. If we want to fill this array with integers from 0 to 9, we can just loop through the entire array and then fill each index with a number. But as you can see here, when we try to run this, it again gives us an error of null pointer exception. Does anyone think they know why this is happening? Okay, so this is mainly because over here, in this line, we haven't yet initialized the array. So what's happening like behind the scene right now is that the array numbers isn't actually pointing to anything in your memory. So when you loop through it and you try to access its first index, for example, it's not pointing to anywhere yet, so it can't access that index. And then we can resolve this just by initializing it as this. 10 is just like the length of the array that we want it to be. And now when we loop through it, also just note the syntax of the for loop. In Python, it would be for I in range 10. In Java, it's split into 3 parts. We're first saying that int I equals 0. And as long as I is less than 10, we can add 1 to I. So now when we loop through I from 0 to 9, we will set the ith index of numbers to I and then print it out. And now we can see, wait.
Maggie, what is the plus plus mean?
Oh, great question. That is the same in Python, it's just +1. Yes, ignore the 45 for now, but we can see it just prints out 0 through 9. So all of the elements inside the array of numbers. So now let's say that we want to go through the same array and add all of the numbers together to get its sum. So we can loop through the array, which we can use the same formatting of I equals 0, I less than 10, I plus plus, but that is kind of like, it's pretty lengthy to write all the time. So similar in Python, how you have for value in numbers. In Java, you can just do for int value in numbers. And that will just loop through all of the elements in numbers. And then you add that value to a local variable total, and then it will return total and print it out as the sum is 45. Something else to note here between the two methods, which you might have noticed. In the first one, we have void, which basically means that this function doesn't return anything. So it just runs through all of it, but at the very end, it doesn't give you anything back. For the second one over here, we have int, which means that after we go through all of this, it will return total. And as you can see up here, we have int total equals, we're calling this function, and it's returning total, and we're setting it equal over here. And then last but not least, if you have an idea of what you want the array to be already, like if you know from the very beginning, I want an array of numbers 0 to 9, you can just declare and initialize an array like this. And it would just give you an array of numbers 0 through 9, and you don't have to loop through all the indices and actually like say which index is what number. Did all of that make sense? Any questions on arrays before we move on? All right, cool. So the last intro to Java file is going over array lists. So as you saw before, arrays are a little bit complex in the sense that you have to know exactly at the beginning what your length is. But let's say that you want to have a list of numbers, but you don't know what the length is at the very beginning. This can be done by a different class in Java called arraylists, which basically allows you to have a list of numbers with undefined length at the very beginning. So now let's say that we have this array list. Also just notice that it's basically the same thing as an array, but defined very differently. Instead of like this 2 square brackets that we saw over here for arrays, over here. For array lists, we have this like greater than less than equal sign and an integer in between, just saying that it's array list of numbers. So now let's say that we want to go through this and we want to do numbers dot add 2, 3, and 4. Does anyone think that this will work? Also good. So basically when you run this, we will see that it gives also a null pointer exception. And does anyone know why this is happening or know the solution of how to fix this? Yeah, that's right. So basically we have declared numbers, like we have stated it over here, but it's not equal to anything yet. So similar to how we had the mistake last time of not having new int 10 over here, initializing the array of numbers. Over here, we have the same mistake of not initializing the array list of numbers. So we can fix this by just doing and then now that we have this, now that numbers is pointing to some empty array list in memory, we can go ahead and add 2, 3, and 4 to it and have it be printed out. Also ignore the 9 for now. All right, next, assume that we have numbers.add 3.7. And you can already see that Java is not happy with this. It has a red line through it. And when we run it, it indeed has an error. Does anyone know how to fix this one? Yeah. Yes, all good solutions. So basically we have an array list of integers that we stated up here, but this is clearly not an integer, it's a double. So we can, as he said, we have many different solutions. We can change the array list over here to a double, or we can go here and cast this number into an int, And as he stated, it will change this 3.7 simply into a 3. And then now let's say that we want to add numbers.add null. Does anyone think that this will happen without an error? Well, if we were to run this, we can see that wait. Don't know why it's printing that instead. Oh, yes. Okay. Yes, so over here, we will get to this error later, but basically, this does work. So if we want to add a null to the array, it does work. It just becomes 2, 3, 3, 2, 3, 4, and then null as the last element. And then for this very last one, let's say that we want to loop through this array list and we want to add all of the numbers together. And as we saw before, when we do that, this error comes up. And that's basically because as we're adding all the numbers together, it's fine until we hit the last element null. And Python or Java doesn't really know how to add the variable null to other integers. So that's why it gives us this error of just like some exception happening, null pointer, because it doesn't really know how to add null to something. And then once we comment this out, we can see that it runs fine again. And the final sum of 12 is printed out. Okay, and then that's it for intro to Java. Does anyone have any questions?
I will cover actually a few more things with Java, and then we'll be entering some modifications with robot player, just making example function player a little smarter than what it is right now. So let's first take a look at comparison within Java. There's sort of two things to keep your eyes on here. The first is the conditionals, the if else, and the second thing is this exact comparison that's going on over here. So let's first look over this file and make sure that we understand everything that's going on in the Java file. As Maggie mentioned earlier, package example function player, if you sort of look at our file system on the left here, it's a little hard to see because it's small, but our package is named example function player. This basically indicates where all of our classes are and what can see what within the class. Here I've added an additional import, battlecode.common.star. This basically means import everything within the battlecode.common library, which we provide for you. If you actually want to see what's in the Battlecode common library, we have some very useful Java docs online. You can access these Java docs from our from our resources. But these contain all of the functions that we give you that you can work with that are specific to Battlecode. So we look through this, we have the robot controller, which is sort of how you control robots. We have stuff like clock, game constants, sort of any useful information that comes along with the game, and a lot of other useful things. We'll be going through these things in a bit more depth in a bit, but for now, just know that the Java docs are over here. Here I've imported battlecode.common for a very specific reason. It's because I want to use map locations. Map locations are just XY coordinates. They're found all over our code and probably all over your code too, once we pull this repo. And they're useful for comparing locations, figuring out where you are, figuring out what direction to go, etc. So let's say we have a robot and it's at the location 1,4, and we have an island also at the location 1,4, and they're stored in their respective variables. So this basically means that our variable is of type map location, and here we're just declaring a new map location to assign our variable to. Now, let's say we want to figure out if our robot is on the island. Pretty useful. You might want to know if you're on an island. So we say if the robot is equal to the island, or if the robot location is equal to the island location, print that the locations are the same. Otherwise, else, print that they're different. If you're familiar with Python, this is sort of the same thing as saying robot location is island location. And we see that there's no errors in this project, but there is an error within this project, just not one that shows immediately. Does anybody have an idea of what it might be? It's not the most obvious thing. Yeah. 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 Oh. Yeah, exactly. Sorry for interrupting you. Basically, this is the same thing in Python, but when you use the is, you're not actually checking if the values are the same. What you're really doing is you're checking, are they pointing at the same locations in memory? And for integers like 2 and 3 and 4, this doesn't make a difference. But for non-primitive variables like map locations, for example, this does make a big difference. So what we're saying is, does robot location point to the same location in memory as island location? And we run the code. Let me just move this back down here. We'll see that the answer is a pretty obvious no. So how can we actually figure out, if these two locations are the same? Well, Java instead uses something called dot equals like this and that, like this, to actually compare the values. So if you look at the dot equals method, you can just hover it over it and our Java docs will appear. These are those small. I unfortunately can't make them bigger on Eclipse, but if you just click this button on Eclipse, it'll bring you to our Java docs. And the dot equals, as it says, states that map locations are regarded as equal if their coordinates are the same. So going back to our code, if we now use the dot equals, we can run this and it'll say that the locations are the same. So generally dot equals is better if you're comparing objects that are anything more than like an integer or a character or a double. Just something to keep in mind, as it won't throw an error. So it's not the most obvious issue in your code. Now, let's say that we actually do want to see if the locations in memory are the same. How can we do that? Well, we can essentially just copy the if statement we had before. And it'll enter this if statement if they are actually in the same locations. So we can do something like this, right? And instead of an if, we can use something called an else if. This essentially works by first checking the first condition, then it'll cascade to the next else if that fails, and it'll check the else. So it'll only print if the locations are the same, if they're not the same locations in memory. So if we like try comparing, for example, if we say something like island location is equal to robot location, these should now point to the same areas in memory. And when we run the code, we can see that is indeed the case. Any questions? All right. Now let's move on to some logic. This is all commented out for a good reason. It's because when I uncomment it, 4 errors or 2 errors will appear and Java won't let me run any other code. So now that's uncommented, let's sort of take a look at what exactly this code has. So once again, we have our main function. I've also brought over inventory in common, just so that I can work with these again. But let's say we have an alternate robot. Robot info is the class we use to store all information about robots once you detect it. And this robot, just to walk you through what exactly I've created here, has an ID of 1, is on team A, is of type destabilizer, has an inventory of 40. That's how you know this robot's fake, by the way. Destabilizer doesn't have an inventory. Has a health of 5 and is located on 2.3. You can find the full constructor and what exactly each of these does on our Java docs once again. So what exactly is going on in this code? So let's say we encounter another robot. How are we going to react to this other robot? Well, first pretty good thing to do when you encounter another robot is it on your team? If it's on your team, probably don't have to do anything about it. If it's not on your team, maybe you have to take some offensive or defensive actions. So if the other robot .get team, this will give us the team of the other robot, or team.a, is equal to team.a, then we know it's on our team. Here we can use the double equal sign because team is actually an enum, which means that it's considered one of those primitive things that you can just double equals compare with. So we can print hi friend or something like that. Otherwise, else if the robot is a launcher or if it's a destabilizer, we want to run away. Furthermore, if it's not a launcher or destabilizer and it's on the enemy team, we can check if it's a carrier and if its health is not greater than 10. If that's the case, maybe we can fight back, and otherwise, I don't know, do something random. So you see there's 2 error lines in this code right now, but if you're familiar with Python, this code might look perfectly okay to you. Specifically, if we read the errors, it's a little hard to read, but I'll read it out. It says, cannot invoke or Boolean on primitive type Boolean. And here it says, cannot invoke not Boolean on primitive type Boolean. Not very informative errors, honestly. But does anybody have any ideas of what might exactly be going wrong here? Why is this code not working? You guys don't answer, I'm just gonna have to answer my own question like an insane person, so. Yes. You're not using like the ampersand stuff. You're right with Python. Yeah. So, Python has nice utilities where it looks almost like English. You can just write or and not. These things don't exist in Java. Java is a cruel world. Instead of or, Java has a double pipe symbol. These are sort of the ones you find on the top right of your keyboard if you look there. Instead of and, Java has double ampersands, the one that's sort of sitting on your 7 key possibly. And instead of not, Java has exclamation marks. So maybe less readable to a human, but more readable to a coder. Now we have something that doesn't have errors. And if we run this code, it'll run properly. It'll say, hi, friend, because the enemy robot is on team A with you. Now let's sort of look through the logic here. What if the enemy robot isn't on team A? What if it's on team B? What do people think what do you think we're gonna do in this code? You guys don't have to raise your hand. You guys can just say it out loud, by the way. You guys are the ones who are here for pizza. I'm willing to wait you guys out. Run, yes. The enemy team, it'll do the first check. Is the enemy team on team A? No, the enemy robot is not on team A. So do the second check. Is the enemy robot of type launcher? No, but there's an or condition here. So continue on and check the condition. Is the enemy team, or is the enemy robot a destabilizer? Yes, it is a destabilizer. So hit run. Now, what if it's not a destabilizer? What if it's a carrier and this condition isn't fulfilled? I'll spare you guys answering this question. What will happen is it'll look to attack. And this is because this condition fails, and it'll start looking at this condition. Is it of type carrier? Yes, but there's an and, so it needs to double check that the second one is fulfilled as well. What is the health? The health is 5, and we're comparing it to 10 in this code. So is 5 greater than 10? No, it's not. So compile that with another not, and we get a true statement. So what's going on overall in this statement is that it checks that the robot is a carrier, then it checks that the robot does not have health greater than, have health greater than 10, which is the case. So it prints attack. And lastly, if we increase the health and we run again, we'll end up at this final statement. Stay perfectly still. The reason for this is even though it's a carrier, there's an and symbol here. So it needs to fulfill the second condition to be true in order to actually reach the bottom of the code. Any questions? All right. That's the boring Java stuff out of the way. Now let's actually try running robots and learning how to make robots better. Hopefully that's what you guys are here for. So as you guys saw earlier, we set up a Battlecode 23 scaffold. I'm going to be working off the Battlecode 23 scaffold. This is a fresh scaffold, and you guys should have the exact same copy of code in your computer if you followed along and cloned or zipped to the file up. So as I said, example funcs player is, one robot, but a lot of the time when we run robots against each other, we don't want to see how our robot looks against itself. Maybe we want to see how it looks against, a version previously. Maybe we made one change to our robot. We want to see, is this a good thing? We can fight it against an older version of itself, right? But just in the feature that I showed you before, where we just hit run on Gradle, this is not something we can do. So how can we actually do it within our code? So the first thing is actually making sure that our code has 2 robots in it. Now, example funcs player here is 1 robot. What we can do to create a second is we can just navigate the source and create a new package. Let's just call this example funcs player 2. Very creative naming. In this package, the most important class is just a robot player. So let's just make that. You can just navigate the class, type in robot player, and we have a new file. Now, in our new robot player, we're going to want to take in all of the default code that example funcs player had. So let's just copy and paste that. We'll have to change this top line because we're not in package example funcs player. We're now in package example funcs player 2. And now we have all of our code. So if we actually try running our Gradle, hopefully it works. This is going to be example funcs player versus example funcs player. Now, how can we run example funcs player versus example funcs player 2? There's 2 ways. The first way is contained within client, and it's unfortunately not working right now, but should hopefully be working soon. If you just go to the client, and then you actually pull it up, this is what the runner tab is here for. You can see example funcs 2 has now appeared. You can pit them to the death against each other in this client. Very cute robots. The second way is actually doing it via terminal. So here's our terminal. On Windows, it's going to be command line. And I'm just going to enter the Battlecode 23 scaffold. ls is just used to see what files are around you. cd is just used to enter a file or a folder. Now, there's really a few things here to keep in mind. The first is making sure you have the right Java version set up. You can see I have 1.8 set up. This might not be the default, and you'll need to rewrite your Java home. Instructions are on the play.battlecode.org getting started for this. The second thing is to actually run commands, you can type let me zoom in here, /gradlu, and then write whatever command you want to put in after. So in this case, we want to run. And what we can do is we can add a few things. So we can specify maps by saying -p maps and then giving some map names. And what we're interested here is we're interested in, I believe it's P. Actually, I'll need to double check the command here. We have P team A and P team B. So what we want is we want P team A of example funcs player, and we want to pit it against example funcs player 2. And this will run a game between example funcs player and example funcs player 2. They're the same code right now, so it's not the most interesting thing. But this will generate a match replay file, which you can then play in client. So I'll do that in a second once we start actually making upgrades to example funcs player 2, but just keep that in mind. So now that that's all out of the way, let's actually look at the code and figure out what's exactly going on in this code and how we can improve it. These are just a bunch of useful imports. We have arrays, just like arraylists. We have hash maps. These are just maps that navigate dictionaries in Python, if you're familiar with that. Sets, same thing in Python. Maps are just sort of less cool hash maps, in my opinion. And then we have stuff like random, which is useful if you ever want some randomness in your code, and sets, again, less cool hash sets, in my opinion. Anyways, this is our robot player class. All of our code should be contained within the robot player class, but there are ways to organize your code a little better. I'll be going over that once I finish going through the robot player class. Turn count is just what turn you're on. RNG is just some default random object we've provided for you. So whenever you want to get a random number, you can just query the RNG. Directions, just all 8 directions that are nice and useful. And this is the important function, run. Run is sort of what gets run for every single bot at the start of the match, and it continues until the bot dies or the game ends. So if we look at what's going on here, this is going to be a statement that indicates when the bot gets created. And then we enter a while true loop. Your professors might tell you while true loops are bad. Generally, I agree, but for the purpose of Battlecode, while true loops are great, don't use them too much. But basically, we want this robot to always run until it dies, so we want an infinite loop in this case. Here, we're going to check what type our robot is. Switch case is just sort of an if-else that's more useful for checking what value something is. But in the case of a headquarters, you want to run a special headquarters function, carrier run a special carrier function, and vice versa until we reach these last three. Right now, boosters, destabilizers, amplifiers, not used by example function player. And we will be probably expanding on those in intro to bot, which I believe is tomorrow. So what are these three functions? Well, if we look at these, we can navigate to them. Oh, one more thing, clock.yield. Clock.yield is a Battlecode provided function. You can open it up in the Java docs right here. And what it essentially says is that it waits until the end of the round. So, a lot of your time, your robot does a bunch of stuff. How do you know the round ends? Or how do you know you want to wait until the next round before doing an action? Clock.yield will just wait until the next round. So very useful function to keep in mind. But with that established, let's now look at the run headquarters code. It's nicely commented, courtesy of our engine programmers who coded this bot. I think they made it a little too good, honestly, in my opinion. We are trying to dumb it down before launch, and then we didn't dumb it down enough. And I think we left like 1 or 2 artifacts that have too much intelligence. So hopefully we'll find more places to add intelligence as the lectures go on. But picks a random direction to build in. You can see that we're using the RNG, or the random number generator we created before. We're going to take a random integer from 0 to the directions.length, which is going to be 8. And then we're going to get this and then randomly index into our directions array. So this will just pick a random direction based on the directions array we declared at the beginning. We're going to try building in this. So how do we do that? We first check the map location that this leads us to. So we can get our current robot's location using rc.getLocation. Very useful function. You can check it out in the actual Java docs if you want more information on it. And we want to add the direction to this location using .add. This is, once again, a function provided in our Java docs. If you have time, I highly recommend going through our Java docs. It has so much useful stuff just lying here and there. Functions you didn't know existed, functions you knew existed, but didn't know how to use, etc. After that, we're just going to check if it can build each of the things. If it can build an anchor, we're going to build an anchor. Very not smart behavior. We'll hopefully be correcting this during the lecture. Otherwise, we just roll a random number. There's like a 50% chance it's going to build a launcher, and 50% chance it's going to build a carrier. So if we get a yes on the random Boolean, we're just going to build a robot, or we're going to try to build a carrier, and we're going to build it if we're able to. And otherwise, we're going to try to build a launcher, and we're going to build it if we are able to. Indicator strings are just a nice tool you can use on client to sort of see what your robot's doing. For example, if we go to our client and actually click on the robots, we'll be able to see the indicator strings like in real time. That's all of the headquarters code. Now we're going to look at the carriers code. Pretty simple. Oh, just to be clear, I realized I didn't go over this, but robot controllers are just the general interface we use to provide. You basically use it to access anything around the world, anything that's really like robot related that a robot can do, like sensing, communicating, etc. You'll be working with robot controller a lot. So what does a carrier do? Well, if it can't get an anchor, it gets an anchor. Or if it has an anchor, if rc.getAnchor is not null, meaning it has an anchor in its inventory, it has the single-minded purpose of looking for nearby islands and sending it to nearby islands. So since nearby islands will just access any islands it can see, it will then check all of these and get their outputs. And this is a bit of a confusing code, but it's essentially going to iterate each island, then check which ones are available to the carrier. In the case that there are actual islands available, if island locks.size is greater than 0, it's just going to start running in that direction as fast as it can, which is maybe a good thing, maybe not a good thing. And they'll just like check the direction to go towards the island's location. and then see if it can move in that direction. Direction 2, once again, a very useful command. If you have one location and another, it'll just tell you what way to go to get to the other location. If it's on the island, it checks if it can place an anchor, and if it can, it just drops it down. Pretty simple behavior. Carriers are probably the most confusing part of the default player, so bear with me as we go through this. Otherwise, carriers look to try to gather from wells around it. It essentially just iterates the 9 locations, including its current square, within one distance of it. And then it just checks, is there a well there? So this presumable well location would just be the current location plus the difference. And if it can't collect a resource in that location, it rolls a random dice, and it does if it passes the random dice check. I don't know why the random dice check isn't there, honestly. I assume you should always collect if it's available, but maybe whoever coded this is much smarter than I. Or maybe they're trying to dumb it down like 2 minutes before release. Anyways, in a 1 in 20 chance, we grab a random integer from 0 to 19 and we check if it's 1. If it's 1, we're gonna just like toss all our inventory at the nearest robot. I was gonna say a word there that I shouldn't be saying on recording. And it just senses the nearest enemy robot. And if there's a nearest enemy robot, then that robot suffers the wrath of a carrier, and the carrier loses all its stuff for some reason. Finally, if we just see a well, if we can sense a nearby well within our vision radius, we're just going to move towards it with a chance of 1 in 3. The RNG.nextIn is essentially just rolling 0 to 2 and checking if we hit a 1. And in this case, it's going to get the well location, or it's going to get the well info, then it's going to move towards the well location. Otherwise, if none of those pass, we're just going to do a random movement. You can note that we wrap everything in like rc.can move, rc.can move, rc.can attack. This is for a couple reasons. First, you don't want your robot to encounter an error. This encodes a bytecode penalty, and it's also just not a good thing in general. And second, let's say it does something up here, it hits rc.move, and it keeps on going, and then you don't check rc.can move. Well, it's already moved once, so it can't move again. So if you try to move again, it's just going to throw an error. So 2 reasons for why we sort of have all of these can checks before. All right, that's the hard part of the code over. Now we're looking at the launcher code, which is what we'll be working with today. Launcher behavior, pretty simple, sort of what you expect of a launcher. You try to attack someone, and if you can't, you just wander around like a chicken without a head. So how does this work? Well, first we get the action radius squared. This is the action that the launcher can actually attack people within. And then we get the opponent's team. We only want to attack the opponent. Try to attack ally robots, it'll throw an exception and say you can't do that. So yeah. Next, we'll use sense nearby robots. This is a pretty handy function. The first parameter we can pass in here is going to be the radius of which we want to sense. Here, we just want to use the action radius because we don't want to try to attack robots or detect robots outside of that range. And we only want to get enemy robots of the opposing team. That way we can sort of filter our information a little more before taking it in. If you sort of want to look at what exact parameters this has, you can also just check out the Java docs. Once again, very useful. And then now we're just going to check, did we get an enemy? If we got an enemy, try attacking east for some reason instead of the enemy's location. Not the smartest behavior, also behavior we'll be correcting tomorrow's lecture. So we try to attack, if it works, we attack, otherwise we don't. And otherwise we just pick a random direction and we try to move in that direction. Pretty simple code. It's a lot to take in, so don't feel bad if you don't understand everything that's going on. But before I start actually touching this code and changing it, does anybody have anything they want to clarify or any questions they want to go through? All right, let's get into actually modifying the code. Fun part, boring part is over, guys. All right. Now there's sort of 3 things I want to do with today's code. One is a bit simpler than the other. And the first one is going to be organization-wise. This is a file that is 232 lines long. And you're going to be working with teammates, or even if you're not working with teammates, you're going to want to know where code is, and you don't want to have to scroll through 232 lines, increasing to find where you need to modify something every time, right? I want to find launchers. I don't want to scroll through this and look for the run launcher function. So what we can often do to do this is to separate our code into different files. In particular, today we're going to be separating the run launcher file code all away from everything else. So we can just create a new launcher strategy within our package. So just navigate to our package, hit class, and then we can just create a launcher strategy file. So it's going to start off pretty empty, but we can just quickly just copy and paste our launcher code in here. And all of a sudden, everything's nicely organized, except it's going to throw 2 errors at us. These errors are because even though we have the package, that doesn't mean it can see everything from the other classes. So directions and RNG were created in the other file. So we'll need to use the other file's name to clarify where exactly we should be looking for these values. So if we just add robot player dot on all of these, it'll say, hey, look for these things, look for directions, look for RNG and robot player. I'll take a look at robot player and say, wow, I found these things sitting up here. That's the first change. You'll see robot player also gets an error. You know, run launcher is a function that's sitting in there before, it just mysteriously disappeared, doesn't know where to look now. So we need to do the same thing and indicate that it needs to look in launcher strategy in order to find run launcher. And now our code should work again. If we run our Gradle and we hit run, everything should be smoothly working. And yeah, you see this is working fine. So now that we actually have our launcher strategy changed, let's start making one modification. But before that, let's look at headquarters. Just one quick change. I mentioned this here is like pretty dumb behavior, right? Like we have resources and we're like, okay, what can we spend these resources on? We can spend these on carriers, launchers, amplifiers. No, let's burn all 2,000 on 100 anchors that have no use until like we actually capture islands. So, let's try to make this behavior a little smarter. Besides just checking whether we can build an anchor and building it, why don't we, let's say check if we have enough resource. If we have excess resource, we can build anchors. Otherwise, we can build launchers or we can build carriers. So how can we do this? Once again, RC robot controller is what we want to interact with everything with. And hit RC dot get and then hold on. We can just hit something like RC dot get resource amount. And then we want to specify a specific resource that we want to query. So let's say we want to query if we have adamantium. So if rc.get resource amount, resource type adamantium, if this is, let's say, more than 100, sound reasonable, then we can build an anchor. Otherwise, let's not build an anchor. And the results should be pretty immediate. If we hit run here, it's going to generate a nice match replay file, and we can see what goes on in our client. So let's open up our client and see what that change actually did. So the match replay is going to be, ignore these random match replays as testing our game with. Match replay will be sitting in our scaffold under matches, sort of the most intuitive place. And we will want to see example funcs player versus example funcs player 2. Actually, one thing I need to do before I actually do this is rerun in terminal, just because the other one will just run 2 example funcs players against each other. So here we have our game. Let me update it to the newest file. All right, this is our game. So what do you guys will think will happen? Red has built 100 anchors with no use, and blue has built useful robots. Big change, and hopefully blue will win this match. I don't know, if we fast forward it very quickly, it looks like blue is winning. And yes, blue does win the match. So no small change, big results. And this is sort of the theme of, making a robot. A lot of people look at all of the code and they're like, well, I can make like 20 different changes. I want to have better pathfinding. I want to have better resource allocation. I want to add communication. They have a big vision for what they want their robot to be, but trying to code everything in at once is pretty overwhelming. So my recommendation, in the wise words of Jerry Mao, last year's lecture for Intro to Java, like Battlecode is a lot about finding these small changes, and finding a lot of these small changes might not make might not make such a big difference one by one, but they build up. And a lot of small changes makes a pretty big change in how well your robot performs. So one big recommendation, at least from my side, is when you're working on making a robot, just identify, here this could be better, here this could be better. Let's try these things out one thing at a time and see, do they actually improve our robot? A lot of things sound good in theory. Maybe you want to run away from high health enemies, but that's not always a good idea in the results. So just a word of advice from me. Try to change things one thing at a time and try to make small changes at a time. But with that out of the way, we made our robot smarter. Can we make our launchers smarter? So let's look at this launcher code. 2 parts. First is attack someone if we can. Second part is move in a random direction if we can. Does anybody have any suggestions actually on how we can make this better? If your suggestions are reasonable, I'll try implementing them. Otherwise, I'll go to my base lesson plan of my idea of how to make these better. Yeah, sure. Yeah. Yeah, it is kind of strange, right? Like there's sort of 2 things that are pretty obvious here. It's like, well, enemies.length, enemies is going to be the list of enemies we encounter. Well, I mean, we're always going to be encountering at least 0 enemies, right? So why are we checking if it's greater than or equal to 0? This doesn't make sense. So, it makes sense if there are more than 0 enemies. That's a good thing to attack. Another thing is like, why is it attacking east always? This doesn't make sense. We see an enemy to our left and we check if we can attack right, and then we give up if we can't. So, there is already a nice commented line of code here for us, probably an artifact of engine testing, honestly. But we should be attacking our enemy. We can just like pick maybe the first enemy we see, enemies 0. There might be smarter ways to pick this. Maybe we want to attack the lowest health enemy or the most high priority enemy. But like, why don't we try attacking the first enemy and, pick this location instead of just going east and attacking? So this is a pretty smart change. I agree. This is a pretty good thing to do. If we hit run, let's just make sure that everything is in order and this didn't introduce a giant bug to our system. And yeah, it worked. And if we actually, we'll have to be running on here because I'm working on a separate bot. If you're just working in example functions there, you don't need to do this. If we actually run the same thing now in the client, this should have some smarter behavior. Might not be so obvious, naked eye, but maybe like all the way down here, you see, wow, there's a lot of blue bots and there's very few red bots. Maybe it's because blue bots got smarter. Maybe it's because red bots got dumber. I don't know. But one thing you'll notice is our launchers are actually hitting things. You see that launcher just like zapped the carrier. So yeah, good behavior. Any other suggestions on what we can change in our code? I think there's some pretty low-hanging fruit sitting in the second part of this code personally. Maybe not so low-hanging, but pretty visible fruit. Well, I'll chime in with my own suggestion here. Our attacking got better. We started attacking a little smarter. Why don't we try moving a little smarter? Like moving randomly is usually a pretty bad strategy. There's only so much of a chance that you're going to end up at an enemy if you're a launcher. So, basic ideas for moving smarter is, well, we're a launcher, we want to hit enemies. So why don't we run towards enemies? Sort of very basic idea, but this will take us pretty far, right? So we already have the basic framework we need for detecting enemies around us up in our detect code up here. So we can take a lot of this, we can borrow a lot of it, and we don't even need to redeclare the variables. Our opposing team is the same, our attack radius is the same. We can use this same rc.sense nearby robots function, and we can say, hey, let's look for all visible enemies instead of just the ones in our attack radius. A radius of -1 here just indicates that you want to go as far as you can, just your maximum visible radius. It's a pretty useful number to keep in mind. A lot of our functions will use -1 as a value if you just want to sense at the max range. So this is going to give us a list of robots that are enemies and are visible. So, the next part is let's try moving towards these enemies. So how can we do that? Well, a first thing that would be good is sometimes some enemies aren't attackable. And specifically, I'm talking about one robot, the headquarters. You can't attack headquarters. You can sense them, but you can't attack them. So instead of just trying the first one, you might want to actually look around and what's in our array to see what are we really trying to move towards. And to do this, we can use something in Java called an iterator. And this was introduced in one of our earlier files, but you might have missed it because it was pretty quick to move through all of these different types of loops. But if we use a for loop in Java and let's say we're just iterating through an array of objects, we can use an iterator like this. We declare enemy is going to be the current one we're looking at, and we want to go through enemies. So we separate it with a colon, and we need to specify that enemies is composed of robot info. There's actually a bug here. There should be visible enemies. We want to iterate through our visible enemies. All right, so now that we're looking at a robot, we're looking at an enemy robot, let's check if it's a headquarter. If enemy.get type is equal to our robot type dot headquarter, then we do not want to attack it. And more specifically, we can sort of increase the intelligence with this logic. And we say instead of saying don't attack if it's a headquarter, we can say attack if it's not a headquarter. Here, instead of putting like a not symbol and then the double equals, we can just integrate it. This means not equals. So if it's not equal to a headquarter, let's try attacking. Now, or sorry, let's try moving towards it. Now, how can we actually decide on what direction we should move, right? Moving is based on directions. We have 8 possible directions to pick from, but we only know the enemy location. Does anybody have any ideas on how we could decide on which way to move based on our location and the enemy's location? You might have missed this, but we did cover a very useful function that would allow us to do this. I'll even go through the Java doc so that we can look for this. Map location is probably where it'd be. What is there under map location that might be useful to us for detecting enemy locations and how we can move to them? Anybody have any ideas? You guys can pull this open on your own computers too, by the way. So accessible under play.battlecode.org resources. Yep. Yes, exactly. Aptly named. We want to figure out the direction to the enemy. So let's use direction to. So let's go back to our code. First, we're going to want the enemy's location. You can just do this by saying map location, enemy location is equal to enemy.get location. Very self-explanatory. Next, we're going to want to figure out our location. Map location, robot location is equal to rc.get location. So now that we have our location, we have the enemy location, let's find a direction. And this is going to be robot location dot direction to enemy location. Oops. A few things to keep in mind when you use direction to. Make sure that you're saying robot location dot direction to, not map location dot direction to. Even though in the Java doc it says map location dot direction to, that just means an instance of map location can use direction to. Also keep in mind that's the right order. If you go enemy location dot direction to your location, you'll be traveling in the opposite way, which is not the right direction. So now let's try moving in this direction. RC dot can move and move dir. Actually, Eclipse very smartly autofills for me. Half the time it's not very smart and I have to delete it, but sometimes it hits. If it can move in move direction, we're gonna move in that direction. And this code is really all we need in order to make our robot a little smarter. So let's try hitting run and let's see how this performs. And now entering the clan again, we want to upload this replay file. We can find the matches under our thing. And we want to make sure that's example functions player versus example functions player 2. And now we can, it's in the middle of running another game. So let me just remove those. We play this game, slightly smarter launchers on the blue team. It's kind of hard to tell because the blue team was already smarter than the red team. How can you tell if you're more better? No, this is why you want version history. You want to compare your robots against earlier versions. This is also why I recommend Git, because Git will offer you version history. We'll be covering that in lecture 4. But for now, let's say you wanted to run it against an earlier version of itself. You could just save an earlier version of itself in something like example functions player, and in running this, we'll just pit your 2 robots against each other. All right. You can see blue's winning here. Blue isn't actually smart enough to put anchors down, so it's never actually going to win until it hits round 2000. And theoretically, red, ironically, with its make everything into an anchor strategy, could win this by just slapping down an anchor at the start. And then blue's never smart enough to put down an anchor, so red wins off a tiebreak. I believe that happened to several of our contestants, not saying names. But this is why sometimes the strategy seems smarter, doesn't always mean it is smarter. So make sure that your strategies are actually improving things. Yeah. Yeah, so there's 2 ways to generate replay files. The first way is under Eclipse. If you hit Gradle tasks and you just hit run, this will run example functions player against itself on the default map. Now, this is not desirable behavior always. You want to try different robots, you want to try different maps. There's 2 ways to sort of try that out. You can go to terminal and you can run this command, /gradlu run. It's the same thing, but it does give you the options to select like which teams you want to run against each other and which maps. You can find this on our play.battlecode.org and getting started in installation. Alternatively, once we get our clan runner fixed, you can just pick things there and it'll generate the match replay files. All right. Yeah, so it'll be stored in the match directory. So if you can see where after I run the commands under the 23 scaffold, there's a matches directory and 2 matches have appeared there. All right, so that's everything for the lecture today. If you guys want to stick around or if you guys want to hear more of me, I guess we do have office hours running up until 10. Pizza is in the front. If you guys didn't get pizza, I recommend you grab it now. And if you guys are having any installation issues or if you have issues with Java, just come up to the front. Devs are around the room. We can answer your questions to our best of our ability. But thank you for coming to the lecture.